Hey everyone, welcome to lesson 7.1, which is on Introduction to Functions. Now, we've covered a lot of things having to do with equations and especially linear equations for the past few chapters. And now we are going to move on to a special kind of equation called a function. A function is special because for each value of x, there is only one matching value of y. And we're going to talk about that idea in future sections. But if we can realize that a function is basically an equation just with like a special, unique piece to it, then we're going to be in great shape and set up for really good things in this chapter. Now, knowing that a function, for every x, there's only one y, it allows us to find unique patterns in how things work, right? Since every function is special that way, we can find some patterns to create equations using those patterns. So let's take a look at a couple of examples here. Right, we have three, actually. And these three examples are just charts. And these charts are essentially allowing us to create equations. So like even in chapter 6, like if we look back to chapter 6, we would take word sentences and write equations from it. We would take 2 points. We would write equations from it. This is really no different. We can do the same kind of stuff, right? So let's take a look at example number 1. Example number 1 has an input value and an output value, and that's what's special with functions, right? If I were to draw it, if I were to give you just like a quick overview of how functions work, basically you're going to put something in, basically in x. Here's your function, and we've seen the notation for this before, function. We've seen that f of x notation before. We put something into our machine, we get out a y, right? For every x, there's only one y. Every time we put a number in, we're going to do some math to it, out pops another number. All right, now, knowing that, what we have a whole set of inputs and a whole set of outputs. Inputs are always going to be your x values. Outputs are always going to be your y values. So, knowing that, we have matching inputs and outputs, right? So for this function, if I put 0 in, I'm going to get 2 out. If I put 3 in, I'm going to get 3 out. If I put 6 in, I'm going to get 4 out. If I put 30 in, this is our question here. We don't really know what we're going to get out of that. So, now that we kind of understand functions, now that we kind of understand that we have these matching values going down, it's just a matter of being able to write the equation from that. So, first things first, to write this equation, all we have to do is look at 2 pieces. The first piece that we're going to look at is right here. If you ever see an input of 0 with an output value, this is always going to be my y-intercept. Every single time. So, essentially what we know in this first equation is that our y-intercept is equal to 2. Now, after we've gotten the y-intercept, what we're going to do is we're going to take a look at these next 2 matching values. Once we get those next 2 matching values, those are basically points. They're ordered pairs. They're groupings that go together. So we know that we have, if I put 3 in, I get 3 out. If I put 6 in, I get 4 out. Now that should look familiar to everybody because we've done that in chapter 6 when we have our slope, right? We have x1, y1, We have x2 and y2. And so all we have to do now in number 1 is figure out slope. Slope is going to end up being 4 minus 3 over 6 minus 3, which ends up being 1/3. Okay, so now not only do we have our slope, we also have our y-intercept, and we're able to create an equation here that is essentially y equals 1/3 x plus 2. So really and truly, the majority of this problem is doing what we've done in chapter 6, just writing equations, using our slope formula, figuring out that kind of stuff. So it's a good pickup from where we left off. The last piece that we have to look at in number 1 is this 30. We know that when we plug 30 in, we get something out. The problem is we don't know what that something is. So to solve that, all we actually have to do is go back to our equation and plug 30 in for x and solve. So 1/3 times 30 is 10. 10 plus 2 is equal to 12. And with all of that being said, we've written our equation, we plug 30 in, and we know that when we plug 30 into the equation, we get 12 out. And our ultimate goal is to fill in that missing box. So, that's how we tackle these patterns. We know what things are, we know how to solve it, we're in great shape. So, now, moving on, what we can do is the same thing. Let's look at number 2. So, number 2, just like before, what I told you guys was look at that first pairing. Hey, I've got 0 as an input. So that immediately tells me that my y-intercept is equal to -3. Now we got to figure out slope. And to figure out slope, all we're going to do is look at the next 2 points, which is 2, -2, and 8, 1. I'll go ahead and rewrite those. So we have them, 2, -2, 8, 1. Go ahead and set up the problem. x1, y1, x2, y2. Remember our slope formula says 1 minus -2 over 8 minus 2, which ends up being 1 plus 2 over 8 minus 2, which ends up being 3 over 6, which reduces all the way to 1/2. Now, that lets me know what my slope is. I've got my 2 pieces. All I have to do is write my equation. Y equals 1/2 x minus 3. And the last piece to take a look at is the number I need to plug in. Well, if I plug in 20, I got to figure out what I get as an answer. And to do that, all I have to do is solve. Y equals 1/2 times 20 minus 3. 1/2 times 20 is 10. 10 minus 3 is 7. And so my answer here is 7. Now, even though this is the case with these problems, I can also show you the same kind of problem just a little bit differently. So where in 1 and 2 everything was written across, in problem number 3 everything's written vertically, and unfortunately for us, we don't know what this piece is, right? We don't know what our y-intercept is. Well, that's not a problem. We can still figure it out. All we have to do is just go ahead and start looking at our slope. Right? So our slope, we take our next 2 points. That gives me an input of 5 and an output of 0. That gives me an input of 10 and an output of 1. Labeling these points, I got x1 and y1 up top, I got x2 and y2 underneath. It's all the same stuff. So that means my slope is going to be 1 minus 0 over 10 minus 5, which ends up being 1 over 5. So I know that my slope is 1/5. I don't have a y-intercept. I actually have to solve for that. So probably the best formula for us to use is going to be our point slope form, which is y minus y sub 1 equals m times x minus x sub 1. Notice that, and I'm going to highlight this in blue, that I have my slope. We calculated that. I also have my x1, y1. So all I have to do is plug in those values. Doing so, I get y minus 0 equals 1/5 x minus 5. Okay? So we know that y minus 0 is, there's no math actually happening there, so I can just rewrite the problem as y equals 1/5 times x minus 5. And then we can use our friend, the distributive property, to simplify. And that ends up giving me y equals 1/5 x minus 1, which tells me that my y-intercept, which I'm going to highlight in green since we've been using green for that step, our y-intercept is -1, which tells me that this number right here should be -1. Okay, so using these patterns, we're actually able to solve and simplify equations. We are essentially writing and rewriting equations from patterns. We got to know where the y-intercept comes from. We got to know where the slope comes from, right? Essentially, it's the exact same stuff over and over again from chapter 6. You're just seeing it in a new way. So, hopefully, these 3 examples have helped you see what you need to do, how you can get your points and calculate slope, how to look at different problems, and go and create your equations. Hopefully this has helped you out, but as always, if you have any other questions for me, please reach out to me and let me know.